Hello everyone, welcome once again to Don Maths class. So today I'll be solving this integral calculus question. So now it says what? Integrate in x. Do you get that now? So now if you want to integrate this, because looking at it is a kind of difficult, isn't it? Good. So now, but there is a particular method we are going to use to solve it, which is integration by parts. Do you get that now? So we are going, I hope you should have heard of the integration by parts formula. So that's the formula we are going to use to solve this question. So without wasting much of our time, let's get started. So now we have what? In integral, so solution. So we have what? That in x. So the x, right? So this is what we are asked to integrate normally. But this is what I want you to understand, that because we are applying the uh, integration by pattern formula, so we have to do what? We have to add one here. Do you get that now? So, but before I do that, let me write out the formula. Let me record the formula so that you'll be able to understand what I'm saying. So we have, so recall, we have what? Integral u dv is equals to what? We also have uv minus what? Integral what? V du. Do you get that now? So this is the integration by part formula. Now, what I was saying there is that we have to include, find a way to manipulate this. No, integral is all about manipulation. You get that now? We manipulate questions most of the time in order for us to solve it, to get our actual what? Result. Now, so we have this. So now we have to represent u in this, what is what? In this our question. You get that now? And we also have to represent the v in this question. Do you get that now? So in this expression now, so our u, but whatsoever we will let to be our u is something that we can easily what? Is something we can easily differentiate. Do you get that now? And also whatsoever we are representing with our dv is whatever we can, is whatever you can what? You can integrate in this expression. Now, looking at this expression now, I told you. So now let's first choose our u. So this our u will be what? Will be in x. Why? Because it is easily for us to what? To differentiate it. So, but we can still rewrite this. So because we are also going to find this our dv, and this our dv, I told you that is, see what? You can represent it as 1. Now, why did I say you can use 1? Because now this is also the same. You can rewrite this as what? The what? So open brackets in x, then what? 1, the what? The x. This is the same as this. You get that now? So 1 times any entity is still that entity. How do I mean? 1 times 1 million is 1 million. 1 times sin x is what? Sin x. 1 times cos x is what? Cos x. Do you get that now? So now, so we can still, writing this is still the same as this, so we are still correct. So therefore, we can let our what? So since we can easily differentiate our what? In x, so we can let our u to be equals to what? In x. Do you get that now? So therefore our u is equals to what? U is equals to what? In x, which implies that what? It implies that what? So because, so we are using this formula, so we are going to look for u, v, and what? We are also going to look for du. Do you get that now? So from all this, so now from this, now we get our u, which is this, but we are going to find our what? Du. You get that now? From here, du is equals to what? du dx is equals to what? We are differentiating with respect to x, which is equals to what? Which is equals to 1 over what? Over x. Do you get that now? Is equals to 1 all over x. So that's our du. So now we also have and also we can just see solve for that by saying du is equals to what? 1 over x what? Dx, right? So which is still correct. You get that now. So now let's quickly find our what? Our v. You get that now. So from this now, our dv is what? Is 1. You get that now. So our dv is equals to what? 1. So when we are saying dv is equals to 1, we are assuming that we have differentiated something before to give us what? 1. So therefore, we are going to integrate this back to what we differentiated. You understand that now? So this implies that, so you know what we are different when we are whatsoever we are whenever we are integrating this thing, what we get is what? It will give us back what we have differentiated. You understand that now? So now when we integrate 1, we will get what? So our v will be what? Our v will be equals to what? That is, if we are integrating 1, our v will be what? Our v will be what? Will become x. Do you get that now? So now we have gotten u v, and we have gotten our what? Du d. Yes, du. You understand that now? So now, without wasting much of our time, let's quickly solve it now. So we have what? Let's now input this formula. So we have s integral what? In x. So this one is the same as this. So I prefer to write this one just for a little work. You get that now? Is equals to what? Is equals to. So now, what is our u? Let's put all this, what are our parameters into the formula now. So now, what is our u? Our u is in x. You get that now? So what is our v? Our v is what? Is x. You understand that now? Our v is x. We have gotten our v to be what? X. You get that now? So now we now have minus what? Integral what? What is our v? Our v is x. We know that our v is x. Then what? Then what is our du? Our du is what? Our du is what? 1 over what? X. You get that now? So it's 1 over, we have what? 1 over what? X. You get that now? So dx. You understand? This is dx. You understand that now? So it's very, very simple. So now, let's continue. So this is equals to what? So we can also rewrite this as what? As x for initial work in x. You understand? Minus. You get that now? So now this x. So x times 1 will give you what? No, this x, we cancel this x. You understand? So we have what? Integral what? Integral dx. Do you get that now? So which is equals to what? X in x minus what? So integral dx is also the same as what? It's also our what? X. Do you get that now? So it's just like we are integrating 1. I've told you already. You understand? It's just like imaginary 1 here. So integrating that 1 is what? You know, this x cancel this. We have 1 left. You understand? And integrating the 1, what do we get? We have x. So it's very, very simple. You get that now? So x plus what? Plus c. So this is our final answer. So if you really love my solution, I will implore you to like and share this video, subscribe to this my channel.